Hi, this recording is for Math 20-1. This is a snippet out of a lesson from March the 3rd, 2015. And the big idea in these next few minutes is domain and range and comparing them between an abstract function and a contextual word problem. So let's take a look at what's happening. On this slide you see y is equal to the absolute value of 2x minus 3. The function itself is out of chapter 7, I think, the chapter on absolute value. So that's the graph of it there, that you can get that graph out of your graphing calculator. We tested some values for x and determined what the value for y is. And so we got these two pieces of the function and we talked about them a little bit. But the focus of this recording is how we define domain and range. So you can see that in the horizontal direction this graph grows infinitely. So we would say that x is an element of real numbers, and so all real numbers, it's a continuous graph. They aren't dots, for example. It's a continuous line. The y has a bit more of a restriction. The y never drops below 0, so we say y is greater than or equal to 0. Y is an element of reals. So this is the abstract problem. However, when you get to a problem in a context, things change a little bit. Let's take a look. There. So what I've defined here, I think I have to go a little bit. No, that's exactly right. I've defined here a problem where someone is designing a stained glass window, and that very same V is sitting in the very same spot in the graph. However, it's truncated. You can see that it stops in these corners where I've drawn the box around. So this is the window, the dimensions of the window. So there are 3 sections and they're all going to be a different color. So we need to talk about the domain and range in this context. And so we need to notice that, I'll just fast forward here a little bit. Oh, maybe I can't. There. So we have to notice that the x values now fall between -3 and 6. We can move all the way to -3 in the horizontal direction, all the way to +6. Then we have to notice what's going on in this problem for the y direction. And not only do we have a minimum of 0, but we have a maximum of 9. So we have a more constrained, a more restricted domain and range in a contextual problem. Other kinds of things you might want to consider in a context problem is that velocity can never be negative, or height of a person can never be negative. So you would eliminate all values under 0 in those 2 cases. There will be other real-world circumstances that will dictate the domain and range. I can think of if you were going to a movie with friends and you were graphing the number of friends on the x-axis and the cost of going to the movie on the y-axis. You wouldn't be able to buy 1.5 tickets. You could only buy 1 ticket, 2 tickets, 3 tickets, 4 tickets. So your graph would be dots, and your domain and range couldn't talk about all reals. It would have to talk about the specific numbers. So that's where context comes into play. Okay, hope that's helpful.